Merge sort is a divide and conquer sort that uses two arrays. We merge from the source array into the auxiliary array, then swap which array is source and which is auxiliary for the next level, so we only need one extra array. Use it when you need guaranteed O of n log n time and stable sort, with only O of n extra space. Key idea: two arrays only. At each merge step we read from one and write into the other, then switch roles, minimum extra space, no copying back. We use exactly two arrays of size n, the input or current source, and one auxiliary array. Same length, no other temp arrays. Divide, split the range in half. If the range has 0 or 1 element, we're done for that range. Merge, from the current source array we have two sorted halves. We merge them by comparing the two fronts and taking the smaller, writing the result into the other array, the auxiliary. We read from source, write to auxiliary. Switch roles, after we finish merging for this level we swap. The array we just wrote to becomes the new source for the next level, the one we read from becomes the new auxiliary. We never copy back as a separate step, we just alternate. Why it works: we always merge from one array into the other. After log n levels the sorted result ends up in one of the two arrays. We only need two arrays total, so extra space is O of n. One merge, we have two sorted halves, 5, 6, 7, 8 and 1, 2, 3, 4. We use pointers I and j at the fronts of each half, and k for the right position. We compare, write the smaller into output at k, and advance. Compare 5 and 1. Take 1, write to output. Advance j and k. Compare 5 and 2. Take 2, write to output. Advance j and k. Compare 5 and 3. Take 3, write to output. Advance j and k. Compare 5 and 4. Take 4, write to output. Advance j and k. Write half exhausted. Copy 5 from left, advance I and k. Write half exhausted. Copy 6 from left, advance I and k. Write half exhausted. Copy 7 from left, advance I and k. Write half exhausted. Copy 8 from left, advance I and k. Done. One merge turned two sorted halves into one sorted array. At every level, the source array has sorted runs. We show run boundaries with a vertical line. At level 0, each element is a run of size 1, so there is a line between every pair. No merges or swaps yet. Level 1, merge pairs. A is source, B is auxiliary. We merge from A into B, numbers move to B. Level 2, B is source, A is auxiliary. We merge from B into A, numbers move to A. Level 3, A is source, B is auxiliary. We merge from A into B, numbers move to B. Done. Merge sort turned 6, 5, 4, 3, 2, 1 into 1, 2, 3, 4, 5, 6 using 3 levels and roll swapping. Time is always O of n log n, we have about log n levels, and at each level we do O of n work, one merge pass over the array. Space is O of n for the one auxiliary array, because we switch roles, we only need 2 arrays total. Plus O of log n for the recursion stack. Merge, we read from src and write merged result to AUX. Left is the start index and right is the end index of the range we're merging. Mid is the end of the left run, so the left run is from left to mid and the right run is from mid plus 1 to right. Both runs are already sorted. Same again, left run src left to mid, right run src mid plus 1 to right. I points to the start of the left run, J to the start of the right run, K is where we write in auxiliary. All start at left, J starts at mid plus 1. While both runs have elements, I before or at mid and J before or at right, we compare and take the smaller. If the element at I is smaller or equal, write it to AUX at K and advance I. Else write the element at J to AUX at K and advance J. Advance the right position K after each write. Copy any remaining elements from the left run into AUX. Copy any remaining elements from the right run into AUX. Sort, we sort the range from index left to index right. Left is the start and right is the end of the current range. Mid will be the middle, the split point. Base case, if left is at least right we have 0 or 1 element, so return. Mid is the middle index, left plus right divided by 2. That splits the range into left half and right half. Recursively sort the left half. We pass AUX and src swap so the child writes into our src, that gives us the sorted left run we'll merge from. Recursively sort the right half, again we pass AUX, src so the child writes the sorted right run into our src,